which I also show you guys. So this is the panda. So I imported. Let me import it. Then I read a CSV file which I have in the same directory. That's why I just put it there. So I run that. This is CSV file we got from the data collection. Then I now run the data. This is this. So it consists of 10,000 rows, 10,000 plus rows, and 35 columns. So I made a duplicate. This is just a duplicate of the original CSV file, so that you can know how to manipulate the original CSV file. So in case if we are making any mistake, we can also come back at the top and start from beginning, and without losing our CSV file along the way. So we'll now create a copy and we'll run that. So we now try to check it out, and it's also the same. There's no difference between the, but it's not that much. There's no difference between them, as you can see. So that's it. So this print function is optional. The reason why I do this is so that I can see all my columns. Why I'm on the reason, so because I'll be removing many columns, so I have to be seeing all of. I have to be going through all of them to know the one that will be eliminating. That's why I did that. You can your own time. You can also wish to do it or not. So it all depends on your choice. So that is why, okay, these all the columns. Let me scroll through. See, 35 of them. I cannot. You can. So yeah. Okay. Then the info. Yeah. It's just giving an information about the data frame, which I had gotten from our CSV file. So yeah, give me this. Yeah, this is your data type. These are the columns. So there's not much to talk about that. So yeah, we have to be dropping relevant columns. Now I have to drop columns on collection, because the reason for that is that in the collection I don't need collection in my analysis. My analysis focus on tracks only, so there's no need for me to include collection there, because it's not needed. So that's why I dropped them using the drop function. And the axis set to 1 was that this 1 simply means it should drop based on column, 0 is rows. So I did that and I run this, and I have this. I've dropped them. Before it was 35, but now 26. So now I check the I also check the uniqueness between the data sets. Like I use this lambda function. I use the apply to apply this function throughout the data set to check how unique all the data are. So I noticed that type, wrap type, and kind are not there's no unique value. They are just repetitive. So I have to remove both, and also the currency and country. So I have to remove them. Although I removed only 2 here, but I also removed the others. So the same way of dropping others, I dropped them. So I now run the data frame again. So I now come down from 26 to 24. Okay, then I now went to the track name. On this track name, I was trying to check the uniqueness between that. The reason why I want to check if these are the same. They are the same in because if 2 columns are the same, there's no need of having both of them in the same analysis. So it's just better to remove one and leave the other. So obviously they were not the same. I run the uniqueness, but when you run this uniqueness, you see that like on face value you think that they're the same. How you see them, but not the same. Although I made a mistake on this comment, which I will have to edit before putting on the description what I said there. So they are not the same, but I still have more reasons to delete this, because I don't need it to. What I just need is the track name. Only the sensor name will not be needed in my analysis. So I actually dropped it here. Yeah, I actually dropped it. Some of these comments was okay. Yeah, so our assumption was actually wrong. There's a difference between the both, but yeah, but still our analysis have nothing to do with. So yeah, okay, I made the right comment here. So I have to drop it too. So there's no need for that. So I have to drop all the columns relating to URLs. Is of no need to our analysis. So that I call them irrelevant column. They actually have no. So our data set, the column actually reduced significantly. So I've dropped that. And on the 5th part of the removing the irrelevant column, I say we will also remove other columns that are not also relevant to analysis, like the discount. I don't need that. Discount, the disk number, I don't need that. The track count, well, I don't need that too. The track number, I don't need it too. The track time in millimeters was not needed, so I have to delete those because I know what I'm trying to analyze is the content of the tracks. So I don't need all these, so that's why I removed them. So the answer to this column I also have to drop again, so I dropped these two. I could have dropped it earlier on, but I forgot to drop, so I just drop them here too for further analysis. So finally we have to drop the artist ID and track ID because they are not important too. Their ID is based on the platform, like the ID used to identify them, the platform, which is the iTunes store, but I don't need it to my analysis, so I don't have anything to do with the ID. It's not going to give us any result that way. So now our table is looking much more beautiful. Now we're having only 1, 2, 3, 4, 5, 6, 7, 8. It's only 8. I also have to drop one more, which is this, because I will not be needing it too. But well, let's go. I will drop it later on. So now, after dropping all the column, I have to now handle missing values. I have to handle what? I have to handle missing values. Okay. So here's where I start to handle missing values. Now, let us check if there are missing values in the data frame. So this is what I used to check. Is null, and I get the sum of the missing value throughout the data set. So when I run this, I get this. Now that we're having 0, 0 missing values. We're having missing value in only the track price and the content adversary ratings, which I will be reviewing at the end of the day, because we're having 10,000 plus rows and we're having 9,000 missing values, which is a big number. And even though if I try to use imputation to fix this will still affect our analysis in some way, because it's too large. Yeah, that's it. That's not how to use. That's the word I want to use. So let us deal with track price. You can just use the mean to fill up the word this is. So you can use the mean of the track price since it's not that much. Just use the mean to fill it up. All those using the imputation technique. Use the mean. You can also use the mode, median, and there are also others in advanced machine learning, like I may not remember them, but there are also other advanced technique. But for data analysis, you just use this one. Just fill in. Yeah, you just get the mean. They're now filling this mean. I fill in the mean, which is this co-mean, in the column. I just fill the NAs in the column. So that's what happened there. And I'll view this. Okay, it has been filled. So you see, I've ended up with 8 columns from 35 all the way to 8. So there's a concept here I want to explain to this checkpoint. Now this checkpoint is very, very important. Remember, we also use this copy at the beginning. This is very, very important. The reason for this is that when you use checkpoints in your codes, it's easier for you to make your corrections with fewer runtime. What I mean by fewer runtime, like, assuming I made a mistake along this line. Although there was a mistake I made, but I have to restart the video again. But assuming I made a mistake and I've got this checkpoint, you understand? Instead of me starting from the beginning, going at the top and maybe running all cells, I could just create this checkpoint. Now, any mistake I make here after this checkpoint, I'll come back and start again from this place. So this is actually helpful when you are working with larger data set. Like this data set is just 10,000 plus. You may be working with a data set like 1 million, 2 million. In such data sets, it's very, very hard for you to go back and run our cells. The time is not even there. So let's run our checkpoints. So it just duplicates our DF data frame and put it here. But DF data frame is still existing before this. It's still existing now until now, but we just kept it on just like a backup file. Then we'll now use this now for now. So it also have the same property. There's nothing different between both of them. So we have to drop only one row. Okay, yes, so dropping the only one row with NA in release dates. Now there's a place I didn't release dates also have one NA. Sorry, I didn't saw that earlier on. So I have to drop that too. So that's the need for comments in your code. It will help direct the person. I think someone else is reading this, to help direct the person. Okay, this this is what you have to do here, and this is what happened there, and also just like a report. So I dropped that too. The reason I dropped that is just 1 out of 160, 10,000 some 10,000 plus. So there's no need of dropping it to not have any effect on our analysis. So I convert the release date to a datetime data type instead of an object. Now it was an object when I ran the data type. It was in an object. I could have seen that, but it's at the top. It was in an object. It was in an object format, so I have to change it to a date time. This is done for us to get rid of the time included with the so I have to, the reason why I did this is to get rid of this. What I just need is the date. So I want to just get rid of this time included in the what's in the time. That's why I converted first of all to a date time. So this is why I did it. I say PD to date time, so I converted it. So after that, the reason why I'm having looks like a warning here is that this data frame here, assuming I use this, it will not have that warning. It's trying to tell me that I'm using a copy of the original data frame. So, but that's not much problem. Just that's what it's saying here. So let me run this now. So I've converted to date time now. So it's looking like this. So yeah, I have to get rid of the time now. So this dot loc is used to locate the column. Now this is for the row, so it's going to locate all rows, but specifically what I'm interested in is the column part. That's why this dot loc is doing here. So it located that, then you have to extract only the date and leave the time. So if I run this and then run it for you to see, so the time is already gone. So that is already gone. So now, so we have to convert the date time back to, we have to convert the release date back to date time, because after getting rid of it, it was converted to an object. This is it. It's converted to an object, so I have to convert it back to date time. So this is what I did here, and it's also showing that error. I've already explained why. So this way. Now, what I did here was that normally in programming language or computer system, or I don't mostly the programming language, they normally have this format of year. I think this month, yeah, something like that, yeah. But it's year, maybe month, yeah, month and day, yeah. That's it, year, month, and day. But I don't need it to this. I want it to be day, month, and year. So that's why I use this. So I don't want it to do this. I want it to be in this format. So that's why I used that. So I use strips time and this function to do this. So not much to do. You also gave me the same error. I will explain why. If I run this now, you have been converted, and I want this slash because I'm more familiar with this than this. So this place, as I will have to drop this. Like I've said before, I have to drop it because we're not needed. And secondly, the missing value is too large, so I have to drop it too. As this on the column, this how anyway. It's just trying to say, due to the contents is only having this column is one only having the data, only having NAs now. So what this thing is doing is just trying to locate anywhere it sees NAN. You should delete that column. So that's what the column. That's what the code is doing there. So when I run it and I run this, so actually the converse contents whatever is removed, and I'm left with 7 columns. So from 35 to 7, that was big shit. So now this handling the negative values in price columns. So now these negative values, I notice these negative values, we have a negative value on the price. Before I notice this, in data analytics, sometimes before you may notice a problem in cleaning, sometimes you may clean your data. Maybe you are done with your cleaning of data. You may now want to go to test visualization. You may notice that there are some things you need to clean properly. You come back. So before I did this, I came I've already on data visualization. I have to come back and check out this price because I was checking for outliers. So I saw this -1. Yeah, so I was saying it's not normal. So I went to do research. They told me that sometimes it's from the API, maybe some error. So I have to fix that. So that's why I have to remove this. So I'm checking out how many they are in the column. So I used to check how many they are. They are actually 300 and not that much. So I have to also remove it because it's not. So dropping them because Okay, dropping them because the number will not have much impact on all this. I have to drop them. It's just 372 out of 10,000 plus, so it's not going to harm our analysis in any way. So I'll view that. So it's already been updated. Okay. So I have to confirm, that is very, very important. So it's not more there again. So there's nothing like negative here. So this value mapping, so to confirm that. Then the value mapping, why I did this value mapping is that previously, this is how, I don't want this thing to be not explicit like how it's combined here. And explicit, because they are trivially explicit here, there. I don't want it to be non-explicit. And it's even smaller, they are not consistent. So I want it to be this way. In a way, it's more better for me. But later on, I changed this in the visualization because I used the more better word like inexplicit, which is no better. I changed that. So I ran that, I changed it. I used this function, replace, and let me check it out. It worked. So and then we're done with the cleaning. So that was all about the cleaning. So now we're on exploratory analysis. Now exploratory analysis is where you have to explore what exactly is going on in your data. Like just like I'm trying to research, I'm trying to go through your data and know patterns and and all those things. So outliers and like I've said before. So checking some descriptive statistics is also part of it. So if I run that, I'm having this. So now we're having counts, how many data is, how many unique data we have in artist name. So I'm not surprised that we're having only 3,000 because sometimes artist name can also, so that's having 3 unique. Then the track name, only 7,000 unique. The others are not unique. That is just telling us that 3,000 or like okay, I think 3,000 plus are actually not unique, which is possible because sometimes two people may have the same track, name and all those things. So they say at the top, the most frequent listing are various artists, which is appeared 235 times. So this one appeared more on the artist name, and performer track name appeared more. So there's not much in all this, and this date appeared more. Not explicit, we're having more not explicit, which you also see more in data visualization. And hip hop have the highest frequency, which you also see most of that. Is this streamable? I don't think that is needed like that. So there's not much here. So then we'll now have to save the clean data, which is what they have here. Click on that and save it. So we save the clean data, index equals to true, the same thing. I don't need this index to be saved. So the next will be on data visualization. I also do some part of exploratory analysis I'll be using Tableau. So I also do it to show you if there's any outliers in any of the data. So before I now go into visualization. So thank you all and goodbye.